Hello, dear students. Welcome to the channel and welcome back to this playlist in which we are discussing about corona over voltages and transients which takes place in the power system. Uh, we started things out with corona. So, in the very first lecture of this playlist, we learned how the corona is formed, what is basically a corona, and how corona affects my transmission line. We've also seen few effects of corona on transmission line and other effects which are not particularly on transmission line but does affect other systems around it. We have seen some important terms related to corona like critical disruptive voltage, visual critical voltage, and the power loss which occurs because of corona. And today we are going to discuss about the factors which affect the corona and what are the advantages, disadvantages of corona and how we can reduce the corona. And how is it harmful to the system. We basically saw it in previous class as well. So if you haven't checked out the previous class till now, please click on the I button which will be flashing on the top right hand side corner of your screen. By clicking on it you can see the previous video in which we have discussed about it, and once you've seen that video, check out this video, because if you don't have idea what is corona, then there is no point watching this video. First see the corona video and then let's start proceeding with factors which affect the corona. So the first factor which affects the corona is basically atmosphere. We talked about it a little in detail in previous class as well, that the atmosphere or the environment surrounding is the primary factor which affects the corona, right? So because the formation of corona takes place due to isolation of air surrounding the conductors, therefore the effect of physical state of atmosphere will be very much crucial. Like in the stormy weather conditions, the number of ions will be very much in numbers compared to the normal situation when there will be not as much ions as the stormy conditions. So such corona will occur in stormy conditions more often, and uh, voltages as well. Like uh, corona occurs at much less voltages as compared with fair weather, right? So if atmosphere is bad and voltages is less, there is chance that corona can occur. But if atmosphere is good but voltages is less, then there are fewer chance of occurrence of corona, rather than if high voltages and bad weather, stormy weather, there are good chances of occurrence of corona. But atmosphere is not the only factor which affects the formation of corona. There are other factors as well. The second factor which affects is the size of the conductor or the physical condition of my conductor, right? How it affects. So the effect of corona will be dependent on the shape and size of the conductor. And previously we discussed the rough and irregular surface will give the corona uh, more base of occurrence of it. So the irregular the surface, more corona because of unevenness of my surface can be generated, right? And because of that, what will happen, the breakdown voltage will be reduced, and as breakdown voltage will be reduced, then there is pretty much chances of occurrence of corona. Except for that, if I'm having a stranded conductor and it has irregular surface, then it will give rise to more corona than a solid conductor. And this is we have discussed in previous class as well. If I'm having a stranded conductor, or if I'm having a conductor which is non-uniform, which is having non-uniform surface, then it will be having more corona, there are more chances of occurrence of corona in uneven surfaces rather than smooth surfaces. Another point which I discussed or which I want to discuss is spacing between conductors. So if the spacing between conductors is made very large as compared to their diameters, what will happen? You will see the corona effect. Uh, you will not see the corona effect more frequently. Why? Because the larger distance between conductors will reduce the electrostatic stress, which affects the conductor surfaces. And because that thing will happen, because we are avoiding the electrostatic stresses, the corona formation will also be prevented. So the spacing between my conductors will be crucial. Except for that one factor which I have not mentioned in the line voltages. Remember earlier we talked when we defined corona, we said at higher potentials, at higher alternating potentials to be precise. So greater the line voltage, greater the chance of occurrence of corona. If it is low, then there is no charge in my conditions of air surrounding the conductors, and because of there is no charge, there will be no formation of corona. However, if the charge will be more, which means if my line voltages has such value that electrostatic stresses will be developed will be developed across the conductor surface, then it will make air around my conductor more ionized, right? And more ionized the air, there is more chances of occurrence of corona. So line voltage is also one of the primary factors which is responsible for occurrence of corona. Except for that, we are having another more factors which affects my corona. Another one is the frequency. We earlier saw that corona is directly proportional to the system frequency. Another one is the air density. So we saw that corona is inversely proportional to the air density. So at higher altitudes like mountains or hills, when my current density is lesser, sorry, air density is lesser. So in such situation, what will happen? These regions will come will see the corona effect more frequently, right? Compared to the flat areas, because the air density is very less. Then the air conductivity. So the higher the conductivity of air, it will lead the higher corona. And then whatever the effect which occurs of air conductor because of my load current. So if the conductor is at low temperature, then the dew drops you must have seen in sporting events or in open fields, that dew drops may be accumulated on the surface of my conductor in winter season. So what will happen? It will cause larger corona because of this dew drops. We will see which we see in the winter season. Because of them, we will witness higher chances of occurrence of corona. But due to higher load currents, the temperature of the conductor will increase, and the formation of dew will be prevented, and corona loss will be reduced. Then, now that we are familiar with the factors which affect the corona, let's see the remedies, how we can reduce the occurrence of corona or how we can prevent the corona from occurring. So we so far we have seen that the intense corona effect are obviously observed at voltages greater than 33 kVs normally. 33 kVs or above 33 kVs normally the effects has been witnessed. So we have to be careful when we design the transmission line, right? So that we can avoid the corona on substations or bus bar which are rated 33 kV and higher. Otherwise, the highly ionized air may cause the flashover in the insulators or between my phases, and it will cause considerable damage to my equipment. And the corona effect can be reduced by few methods which I am going to mention right now. The first one is by increasing the size of my conductor. So, by increasing the size of my conductor, what I am basically doing, I am what I'm doing, I'm raising the voltages at which corona effect can occur. And because I'm raising the voltages at which corona can occur, the chances of occurrence of corona will be reduced drastically. And this is one of the major reasons that in most of the transmission lines which you will see nowadays are using ACSR conductors, aluminum coated steel reinforced conductors, because they have larger cross sectional area, and they use that area in the transmission line to prevent corona. The second point is by increasing the conductor space. So by increasing the spacing between my conductors, the voltages at which corona occurs is raised again, and because of that we are eliminating the corona possibility of occurrence of corona. However, this spacing between the conductors, if it is too much, then that is not very much preferable as well. So if that happens, then the cost of the supporting structure will be too much, right? If two conductors are very far away spaced, then the supporting structure will be costly. Supporting structure, by supporting structure I mean um, cross arm and supporters of my cross arms, like the tower and all, right? And if that increases, so the cost of my whole system will be increased as well. Another point which I can think of is the operating voltages, right? If I operate my line at lower voltages, then there will be less chances of occurrence of corona, because we saw earlier that higher the voltages, higher the chances of occurrence of corona. So by reducing the line voltages, by operating my system at lower line voltages, we can reduce the occurrence chances of corona. The next point we are going to discuss is the pros and cons of corona, or in layman's terms, advantages and disadvantages of corona. And we have already seen that corona is having more disadvantages compared to advantages, and because of that we try to avoid such conditions, we try to avoid occurrence of corona. So let's see them one by one. So first advantage is, because of this formation of corona, the air which is surrounding my conductors will become conducting, and as the air will become conducting, the virtual diameter of my conductor will be increased, right? Because air is conducting, so the conduct air is also conducting my the conductor was also conducting, so the air surrounding conductor will also act as a conductor, and because of that the virtual diameter of the conductor will be increased. This increased diameter will reduce the electrostatic stresses which normally gets produced between my conductors. So this reduction of electrostatic stresses between conductors is one of the advantages of it. Another advantage is it reduces the effect of transients which are produced by surges normally. So that is also one of the advantages of corona. But unfortunately, the advantages are only these two. But compared to that, we are having more number of disadvantages. And what are these disadvantages? So normally, whenever we see corona effect, we see it is getting accompanied by a lot of loss of my energy. And because of this loss of energy, the transmission efficiency of my transmission line is also getting affected drastically, which is not very much affordable at all. Another thing is, whatever ozone is produced by corona, it will may cause corrosion of my conductor because of the chemical reaction which takes place, right? Remember earlier we saw how ionization uh, triggers the corona formation, and because of this ionization there will be ozone which will be producing, and it will surround my conductors, and because of this ozone you will see corrosion in my conductors. So the life of the conductors is getting affected. Third point is, whatever the current which is drawn by the line because of corona, it will become non-sinusoidal, and it will have third harmonic component as well in it. And because of this non-sinusoidal voltage drop, there will be inductive interference with neighboring communication lines, and this inductive interference is not very much preferred as well, right? Except you are working for some intelligence agency, intelligence bureau, and you want to do it on purpose, right? So these are the pros and cons of corona. Now next thing which we are going to see about corona is the how we can design a line which can prevent the occurrence of corona in particular. So we already discussed that how normally a line greater than 33 kV suffers the corona. So whenever we design a line which is going to be operated at greater than 33 kVs, we have to be careful that my corona doesn't take place in these lines. And these lines are normally the lines of substations and bus bars. And if we don't take enough care about the occurrence of corona in these lines, then the highly ionized air may cause the flashover in the insulators, and because of that, a heavy damage can occur to my system, particularly transmission line and conductors. And because of that, there will be damage in conductors, or uh, even worse, there will be flashover which will harm my conductors. And the biggest disadvantage of corona is the power loss. So the corona loss will reduce the transmission efficiency, and because of this power loss there will be transmission efficiency reduction. And if this design is not very much accordingly, then you will not be able to prevent this loss. So you have to consider that thing as well whenever designing a transmission line, that corona should not affect the efficiency of your transmission line. After that, in the bad weather conditions like thunderstorms, fogs, or even rain, you can see the occurrence of corona is you can see the occurrence of corona more frequent than in normal condition or normal weather. So you also have to take care of conditions in which you are establishing transmission line and its weather conditions. And another point, whenever we design a transmission line and whenever corona takes place, the non-sinusoidal current will have third harmonic component in it. And because of this third harmonic component, there will be loss because of corona, because of this third harmonic component particularly. So you have to eliminate this third harmonic component, so that this harmonic component does not induces the inductive interference on my communicating circuits and parallel communication lines. So the design engineer must take care about this inductive interference and non-sinusoidal corona currents as well. Another point is the designer must take care of critical disruptive voltages, right? So at least critical voltage should be 10% more than the line operating voltages so that you can avoid the corona. And what does it suggest? It leads us towards the spacing between the conductors. The spacing between conductors should be more. And the radio interference aspect of corona should also be taken care of. So if I'm having a region where there are rare chances of occurrence of bad weather, it might be better to allow the considerable corona loss during the bad weather conditions. Why? Because it can take the continuous benefit and we can enjoy the higher voltages without any increased cost of line construction, right? So the design engineer should also find good compromise between these aspect to get much benefit, right? Because the better performance, better efficiency, if you want to have, then you have to compromise in cost. If you want to compromise in cost, then your efficiency is getting compromised. So you have to find the balance between cost and uh, compensation of money, sorry, cost and the efficiency. So only you can uh, balance it out and acquire best results. The final point which I want to discuss is what are the effects of corona on transmission lines and the communication lines. So we have seen few effects earlier as well. We have seen what happens when corona occurs to transmission line, because uh, we have seen adverse effect which is produced because of corona on transmission lines and even on wireless signals. I've told you about radio interference, right? So this wireless signals will also get affected because of transmission line. So not only transmission line is getting affected, and this is because of the current pulse generated by corona discharge. So which are other things which are also getting affected? So there will be amplitude broadcasting signal which will be getting affected, power line carriers, aviation, marine ship calls. So all these things, and even the other similar services, then similar services like these are also badly disrupted because of the corona effect. This corona discharge will also affect the spread over uh, this corona discharge will also affects the kilometers of lines in both of the sides. And if the increase of this radio interference field will be uh, gradually up to a voltage a little bit below the minimum voltage at which it will be measurable because of corona loss occurrence, and above this voltage the radio interference will increase very rapidly. So the conductor surface and conductor diameter will decide the rate of the increase of my radio interference, and that is why the conductor surface and conductor diameter are very important here. So this rate is high for smooth surfaces and large diameter of conductors, and vice versa for uh, rough or spotty surfaces and close diameters or small diameters, it will be small. So the designer of my transmission line will also have to be careful about these things, as well as the voltages at which my line is going to be operated, so that he can avoid the radio interference which starts rapidly in the fair weather conditions as well. When the line currents are not smooth and clean, you can see the radio interference will take place very quickly. And sometimes airborne particles on the conductor surface will remain and the darkish coat will appear around my conductor surface because of the formation of carboniferous material, and this coating will cover this scratches and injuries of my conductor surface. So in dealing with radio interference problem, designer has to take care of factors like available signal intensifies along the line, the satisfactory ratios like signal to noise ratio, then effects of surrounding climate on my radio interference, and other factors like that. Another thing which we saw that corona produces inductive interference between transmission line and wireless lines as well. An amplitude module and other similar services are also affected by the interference. So the transmission line conductors are always clean, so radio interference will be occurring there, and this radio interference field produced by my transmission line will be inversely proportional to the radio frequencies. So what does it indicates? It indicates that at higher frequencies the band services like my television, uh, frequency modulated broadcasting radio, microwave related radars, they will also get affected. So the radio interference due to corona is of importance for the lines above 200 kV very much. And all this discussion leads us towards the fact that because of corona, the complications in my transmission lines and even effect of my corona on other things will be very much at higher voltages. So in extra high voltages or EHV lines, the radio noise will be very important consideration whenever we design a line, because the noise which gets produced because of this radio interference will be associated with corona, and it is mainly dependent on the voltage gradient at my conductor. And we already know that corona is associated with my density of air, humidity or atmospheric conditions, wind contaminations, and imperfections and precipitations. So, by experiments, it has been found that radio noise for 750 kilowatt line in fair weather at a distance 15 meters from the line is between 40 to 45 decibels. And in bad weather conditions, this noise will be reduced. So, for frequency modulated radio receivers, television receivers, the noise which is produced due to EHV lines will not be that serious. But during bad weather, this TV reception may get affected near the vicinity of my EHV lines. So these were the effects of corona which takes place on transmission line and other communication lines, and now and also on wireless lines as well. And now to discuss a numerical problem which I wanted to discuss. It is also related to corona. So see the what is the question here? It says the transmission line is delta connected and it is having following data. It is having 220 kilovolt of voltages. We have given local corona MV is equals to 0.72, which is my irregularity factor. We have given temperature and pressure. Temperature is 25 degrees Celsius and pressure is equals to 73 centimeter of mercury. Conductor diameter is 22.26 millimeters. Spacing between conductors is 6 meters, and we have been asked to find the critical voltage, visual critical voltage. So we know what is the formula for visual critical voltage. You can see here we have discussed earlier as well about the formula of visual critical voltages. So see what are the quantities required here. You need R, basically diameter. Except for that, what you will need, so you will require diameter. From diameter you will extract the radius. From radius, after that, you will what you will require, see, you will require the current density, air density. After that, the MV, which is given in the question itself. And then DEQ, or the spacing between two conductors, is also given. So let's find the R and delta first, and then we will implement this implement the values in this formula. So you have given diameter and not the radius. So radius will be diameter divided by 2. Diameter is given 22.26 millimeters. So radius will be 22.26 divided by 2, which will be equal to 11.13 millimeters. Now you might need to convert this millimeters into meters for simplicity factors, and then you will require to find the value of relative density as well. What will be the value of relative density here? It will be equal to 3.86 p divided by 273 plus theta. So basically, this formula is also given uh, in the theory when we discussed about the visual critical voltages. And you also know the value of temperature, you know the value of pressure, so you can find the value of relative density as well. Once you acquire the value of relative density, what you need to do? You need to find the visual critical voltages. And what will be the visual critical voltages? It will be equal to this formula: 3 into 10 raised to 6 divided by root 2 R delta MV into the bracket 1 plus 0.03 under root of delta R ln DEQ by R voltages. And you know the value of R, you know the value of delta, you know the value of MV, you know the value of DEQ. So now that you know all the values, you simply have to calculate the visual critical voltages, and when you do so, the answer will be 130.7 kilovolts. So there you have it. There is your numerical problem. So I will be seeing you next time with a new chapter about the over voltages. Till then, thank you very much for listening, and uh, take care of yourselves.